Hi everyone, this is Sushma, Java trainer. So last video we have discussed about the Java features. So in this video I would like to discuss about JVM architecture. See, everybody know that JVM is nothing but a Java virtual machine which is used to convert bytecode instructions into mission code. But what will be happen internally in the JVM? So let us see. First of all, we have to discuss about JVM architecture. So we are having one diagram. So after discussing that, I will discuss about each and every part in the JVM architecture. So let us see here guys, what is the diagram we are having. Let us go to paint. So if you are going for any interview, especially for freshers, not for experienced person, this question is asked especially for freshers. Can you explain about JVM architecture? So you can ask the interviewer, sir, can you give a piece of paper? I need to explain with a diagram. So that is the correct way you are answering to the interviewer. Why? Because JVM architecture cannot be explained orally, you need to show in a diagrammatic format. After that, you need to explain each and every part in the JVM. Okay, that is the way you can ask to the interviewer. So this is the small suggestion from my side. So let us see here, guys. Okay, so let us see here, guys. First of all, we are having dot class file, right? What we are having? Dot class file. So dot class file is nothing but your bytecode. Dot class file is nothing but your bytecode. Okay, so whatever the bytecode you are having, so this bytecode will be send it to the class loader subsystem. Where we are sending this bytecode? Class loader subsystem. So this is the first part of our JVM. Class loader subsystem is nothing but first part of your JVM. So class loader subsystem. So this class loader subsystem is again divided into 5 parts. How many parts you are dividing into? 5 parts. So let us see what are the 5 parts we are having. So class loader subsystem is divided into 5 parts. So first one is nothing but you are having, first one is nothing but you are having method area. What you are having? Method area. So here we have to write method area. And second one we are having heap. What we are having? Heap. Third one, Java stacks. Third one is nothing but Java stacks. Next, fourth one we are having PC registers. PC registers. And fifth one we are having native method stacks. What we are having? Native method stacks. These are the 5 parts which are present in class loader subsystem. Native method stacks. And next, from this you are having execution engine. You can create a communication with execution engine. So execution engine can contain two parts again. What it is going to contain? Two parts. What are those two parts? So let us see here. Here, first one is nothing but interpreter, and second one is nothing but JIT compiler. So what is this one? Execution engine. So I'm writing here execution engine, which can contain two parts. So that is nothing but first one, interpreter, interpreter, and this can be called it as an JIT compiler. What we are going to call it as an JIT compiler. From this, you are going to create a communication with native method interface. Native method interface. Native method interface. And finally, we are having native method library. What we are having? Native method library. So this is nothing but JVM architecture. What we are going to call it as an JVM architecture. Native method library. So let us see explanation for this diagram. So what class loader subsystem will have, what execution will do, execution engine will do, and what are the parts we are having in the class loader. In each part, what will be happen? Let us see with an explanation. First of all, what we are doing, whatever the dot class file you are taking, the dot class file will be forwarded into the class loader subsystem. So first of all, we have to know what is class loader subsystem. Let us see some explanation for that. So first one, what we are going to call it as an class loader subsystem. Class loader subsystem. So see here guys, first of all, whatever the dot class file you are having, the dot class file from the computer hard disk into the memory. So it loads dot class file from the computer hard disk into the memory. So whatever the dot class file you are taking, the dot class will be loaded into the system memory. Okay. See, it loads the dot class file from the computer hard disk from the computer hard disk into the memory. So dot class file is nothing but bytecode will be loaded into the memory. This is the first point. Second point, then it verifies all bytecode. Then it verifies all bytecode instructions of the dot class file of the dot class file. So if any instruction other than the byte is found, then it will discard the program, or it will display some error messages. Already we know that bytecode is nothing but a fixed set of instructions. So how many instructions we are having? Totally we are having 200 instructions. In this, if any instruction other than the byte is found, then it is going to discard the program or it is going to display some error message. What will be happen in the third point? If all the bytecode instructions, if all the bytecode instructions are all right, if all the bytecode instructions are all right, then class loader, subsystem will allocate memory, will allocate a memory. So they will ask you one question, guys. What is the interview question they are going to ask you? What is the interview question they will ask you? Who will who will allocate memory to a Java program? So this is the question they are going to ask you. But most of the people can say that JVM will allocate a memory. But in JVM, we are having a class loader subsystem. So class loader subsystem will allocate memory to a Java program. So you need to answer like this. So next, class loader subsystem is divided into 5 parts or not? Now we people know what is class loader subsystem. Now we are going to see what are the 5 parts in the class loader subsystem. So class loader subsystem is divided into how many parts? 5 parts. So let us see. The first one is nothing but method area. What we are going to take here? Method area. What method area can contain? Method area can contain class code, method code, static variables, and static blocks. So which are stored in method area? See, class code and method code is stored on method area, or stored on method area. Any variables static variables and static blocks, what we are going to take here, static blocks are stored on method area, So what method area can contain? Method area can contain static variables, static blocks, class code and method code. So second, what is the second one we are having? Heap. Heap is nothing but objects are created on heap. Objects are created on heap. So in heap memory, objects are created. And third one, Java stacks. What is the third one we need to take here? Java stacks. So what are Java stacks? What we are going to take here? What are Java stacks? So these are the memory areas. These are the memory areas where Java methods are executed. Java methods are executed. Okay. So whatever the Java methods you are writing in the program, all the methods will be executed in the Java stack memory. Okay. So Java stacks are divided into small parts. Divided into small parts called frames. Okay, so whatever the Java stack you are having, the Java stack is divided into frames. Okay, in each frame, what will be happen? See, Java stack is divided into parts called frames. In each frame, we can execute methods. See, when we are writing any Java program, the Java program does not contain single method, right? So it can contain any number of methods. So each method can be executed in separate frame in Java stacks. In each frame, we can execute methods. We can execute methods. So that is nothing but what we are calling it as Java stacks. Okay. Now fourth one. Fourth one is nothing but PC registers. So what is a PC? PC is nothing but program counter. What is the meaning of PC? Program counter. So what PC will do? Okay. So let us see here. These registers, what we are going to take here, these registers store the memory address, These registers store the memory address of next instruction to be executed by the microprocessor. So that is nothing but what we are going to call it as an program counter. So this program counter will give instructions to the Java stacks, then Java stack will execute the methods. Okay, so next, fifth point. So fifth one is nothing but native method stacks. What we are going to take here? Native method stacks. So what are native method stacks? These are the memory areas. These are the memory areas where native methods where native methods what are native methods are nothing but C and C++ programs or executed. So that is nothing but native methods. Okay, so these all are nothing but 5 parts which are present in class loader subsystem. Okay, now we are going to discuss second one. So that is nothing but execution engine. Once the class loader subsystem will be done with the 5 parts, we are having execution engine. Why? Because we need to execute a Java program or not. So if you want to execute any Java program, execution engine can contain 2 parts. You people already know interpreter. Interpreter means which can convert source code to mission code line by line. So by using interpreter, the performance of a program is very slow. To overcome that, we are using JIT compiler. JIT compiler is nothing but just-in-time compiler. By using compiler, you can convert source code into mission code in single step. So the performance is increased by using JIT compiler or not. So let us see. It contains interpreter. It contains interpreter and JIT compiler, so which converts the bytecode instructions into mission code instructions. Next, these mission code instructions are created by microprocessor and results are displayed. So this is nothing but what we are calling it as execution engine. So next we are going to see native method interface. What is native method interface? It is a program. What is native method interface? It is a program that copies native method libraries into the JVM. Okay, so this is all about your JVM architecture. So if any interviewer asks you explain about JVM architecture, means first of all you need to draw this diagram and you need to explain each and every part in the JVM. Thank you.